All right, I think we're going to go ahead and get started. Welcome everyone who's attending the first Suffolk U webinar of 2019. We have Tad Thompson, Suffolk breeder, and a great resource for this topic joining us tonight. He's going to talk about sheep reproduction 101, mostly geared towards AI and ET and RAM collections. So hopefully you guys have some get some good information. And we're going to go ahead and allow you to answer questions as we go along. For those that are joining us via Zoom, there's a question and answer box that you can go ahead and include those questions, and I'll monitor that. And then the individuals who are joining via Facebook Live, you can go ahead and comment with those questions, and I'll monitor that as well and give those questions to Tad as we go along. So with that, I'll let you go ahead and start, Tad.
Okay. Well, good evening to everybody that's signed in, and welcome. So we're going to start in and talk about ram and ewe management and the kind of getting ready for the breeding season. Then we'll go into information on semen collection, kind of give you a little bit of a basis on semen evaluation, semen standards, and then we'll touch on the laparoscopic AI setup, and then also embryo transfer setup, and certainly ask questions that you would along the way. So preparation is everything. So the success and failure of your breeding season, whether you're doing everything natural or artificial with some of the technologies we have available today, being prepared is going to be the key to the entire process. I kind of stole this, if anyone's familiar with Maslow's hierarchy of needs. So it's a very similar diagram. It's a pyramid based, and essentially it's very indicative of what we deal with in this industry as well. So level one at the very bottom of the pyramid is the basic physiologic needs. Level two being more of the environmental, and then three is where we're going to categorize the actual act of reproduction. So visually, I want everybody to just be aware of that structure. And so at the base of everything that we do, we're going to have breathing, nutrition, drinking, sleeping, homeostasis, excretion, and certainly genetics. And we'll get into each of those as we go in a little bit more detail. So if we don't have the foundation covered to the best of our ability, then it impacts everything above it. Level two being stress, the environment, which sits on top of the base, and then reproduction at the top. So level one, health and nutrition. So the key is, are these animals healthy? Nutritional standpoint. And when you consider the main nutrient, one of the largest volume of nutrients that our animals ingest is going to be water. So it's the single most important nutrient. Approximately 60% of the body is made up of water. So I'm going to shift gears a little bit from the nutrition talk up there to the immune system, because they actually tie hand in hand. So what is the immune system? So it's a network of cells, tissues, and organs that work to defend the body from its pathogens. So whether those are viruses, bacteria, parasites, anything along those same lines. And when you start to break it down a little bit farther, you look at the GALT system, or the gut-associated lymphoid system. That accounts for approximately 70% of the animal's immune system. So when we talk about nutrition and health being hand in hand, this is exactly where I'm referring to, especially in a ruminant. So we want to make sure. And one of the ways that we do that in a ruminant is through fiber digestion. So the key to everyone today is that the difference between a ruminant and a monogastric. So ruminants being sheep, goats, and cattle, monogastrics being swine. A pseudo-ruminant would be a horse, that are hindgut fermenters. And so the big difference there in our ruminant species is how that rumen is built to break down fiber. And so the rumen is made up of 4 chambers. The stomach in a monogastric, But the first 3 chambers that give us the ability to best. And then also, when these ruminants are able to chew their cud, they regurgitate, remasticate, and re-swallow. And in that whole process, they're generating more saliva and bicarbonate that goes into the rumen. And it's kind of a significant process to keeping that rumen healthy. So cereal grains are very beneficial to the ruminant. I don't intend to say that we cannot feed them any grains. I just think we need to make sure we balance and evaluate our fiber digestion in reference to the higher percentage of what they get in their total diet. So cereal grains are going to be really key for increasing energy in certain points of the breeding season, also pre-patrician or pre-lambing, and then also during the lactation phase. So what we're looking here is if we overfeed concentrates to the ruminants, what ends up happening is the rumen, the pH within that chamber, the big chamber of the rumen, will start to be more acidified, which also can affect the good bacteria that's in the rumen, which allows the bad bacteria to grow, which creates inflammation. You end up with a decrease of the papillae in the rumen, which is the absorptive. It's kind of like the shag carpet that absorbs all the nutrients. That also allows for, as the papillae get shorter or the shag carpet gets shorter, as it turns into a Berber carpet, then bacteria are able to migrate through that rumen lining. So here's a picture of it. To the right of your screen, there's of the papillae coming up, and you see on the left is a normal, healthy appearing rumen. So essentially, the point of what I'm trying to get across there is that keeping our concentrates at a moderate level based on their body condition is going to allow us to, we are able to manage that GI health by higher fiber diets. There are certainly some technologies that we'll talk about in a little bit that allow for increased good bug growth in the entire GI tract, and then also the micronutrients, which we'll talk about here a little bit later, that'll benefit all the other body functions. We want that rumen to be healthy so that it increases the absorption of the fiber. But so on the through the prominences over the top of the spine, looking at the fat cover and the conditions around the transverse processes of that spinal cord or spinal column, as well as the ribs as they go around to the sides. Top middle is going to be a body condition of 2, top right's 3, lower left's 4, and then 5, which is obese, is on the right. So I think it's really important that as we're preparing these animals for the breeding season, so whether it's your rams or your ewes, you really need to know where they're at from a body condition standpoint, because that's going to give you the prediction. If you're going to breed in 30 days or 60 days, that's going to help you adjust to how much they're going to need nutritionally to have them ready to go to kind of optimize their. So we never really want to see any of these animals get below a body condition of 2. Once they get below that 2 point, the point of the body condition score 2, they're going to start doing some catabolism. They're going to be digesting their own body. They're going to be lacking the basic micronutrients they need for everything else to function correctly, whether that's sperm production or whether that's egg production in the ewe. Those are all going to be impacted by the micronutrients. So we really never want them to be below 2, which is where they should be kind of wrapping up in the lactation phase. And as we get ready to breed them, we want to be breeding them somewhere in that 3 condition score, 2.5 to 3. And then as they head into late gestation and lactation, we'd like them to be kind of at that 3.5 at a max of a 4, and never hit the 5 score neutropenias, and some other issues when they start to lamb. So it's really important to get familiar with this chart, comfortable with what it's telling you, and comfortable on how you score your animals. So particularly if you have, if you're raising sheep and you've got a fleece on them, they're going to have, sometimes if they've got an inch or two of fleece, you're not going to be able just to visually look at them and know. You're going to have to get your hands on them and do some palpating to determine that. So what is in a feed? So we want to start with kind of the basics. So the main four components are going to be protein, energy, and what are your macronutrients, and then what are your micronutrients. But all that really ties into the equation at the bottom of the screen. So your total diet is the grain they eat, the hay they eat, are they on grass, and are they drinking water? Impact on what the total diet ends up being. So keep that in mind as you start working through what your production system would be. So essentially, the one thing when it comes to protein that I'll just talk on here really quickly is in our here we'll jump to this screen. So in our most of our diets for our brood ewes or our rams, the mature rams, they really don't need to have much more than a 12% protein. So many times we'll have situations where they're getting fed a 16. And we know there's an immense amount of research that points to the fact that when protein in the diet is too high, that actually affects embryo development, embryo production, and embryo retention. So in the female, you can certainly have embryonic loss based on diets that are too high. And that's not just the grain they get, but if they're getting, if they're getting a 12% grain, but you're going to start to create some problems there. I prefer lesser corn in the diets. Corn is it's a great feed. It creates an immense amount of body metabolism goes on, increases body temperature. So those are all things that can be negative to the rams producing sperm or the ewes producing eggs or embryos. So if you have an immature ram that you're growing up, certainly a 16% protein diet is fine. They're going to be utilizing that in their growth and development. Not a problem with that at all. But once they hit that maturity phase and we have all that excess protein in our rams and our ewes, essentially the excess protein is going to be passed out through the urine and wasted into the bedding, which you're basically paying for a product that you're just going to haul out in your manure. So keeping that in mind on your protein side of it. Energy is one of those components too, where if you're starting with your ewes at a body condition score of 3, they really don't need quite as much energy, and they can do quite well on a higher fiber diet that maybe is built around soy hulls and oats, or even barley is a little higher energy than those two, but those soy hulls and oats could be or cottonseed hulls are a high fiber product that is a little lower in energy. Now, if you're starting with a ewe that's in a body condition score of 2, and you're going to need to increase that body condition and get her a little closer to where you need to be for breeding season, then a little bit more corn in the diet certainly is going to benefit that animal from increased body fats. Getting that energy up is going to benefit her to be ready for the breeding season. Macronutrients just referring to are you feeding oats or corn or barley? What are those going to end up being there? Your micronutrients are very, very important. And so some of those that can really impact the overall health of the animal is a really high quality cobalt. That's going to benefit the rumen flora, the rumen health. Selenium yeast is going to be more available to their system and actually be able to be utilized in all their processes. Natural source E also is going to be a great antioxidant, boost the immune system, and then benefits in the reproductive system. And then the organic zinc also very beneficial in all the different bodily functions, as well as connective tissue development and health, which would draw us back to foot health issues that we commonly see in small ruminants. So those are just 4 of the quick key micronutrients that we want you to be aware of. Not all feed, you really don't know, you won't learn a whole lot from your feed tags. Feed tags are only going to tell you if it's balanced to whatever the minimum or maximum levels are, but it really doesn't tell you, is that product balanced with organic or inorganic zinc. Inorganic is not anywhere close to the quality of organic. Your source of E can affect absorption, your type of selenium. All those things can be balanced with a lower cost ingredient, so there's more profit in it for the feed companies, but it's not benefiting your animals as well. So some of those key questions that have to be asked is, what is actually the ingredients within the manufacturing of the product? Some of the other technologies that are out there are several different. There's a product called MOS product, which helps to benefit some of the overall health, toxin bindings, things like that are going on in the animal. There's different products that actually help increase the immune system, and then also vasodilation for heat dispersion or heat abatement. There are several different products out on the market, but all those add a little bit of a benefit to preparing your animals, especially if you go through adverse or hot conditions through your summertime. So that's a kind of a quick rundown on nutrition. I don't know if anybody has questions on nutrition at this point. Okay. So as we're still kind of in that same level, we're going to talk a little bit about air quality. So in reference to this animal health and nutrition, also keeping in mind, is that air environment good for the animal? Most of these buildings that we'll visit throughout the course of the year generally are, and especially in the Midwest, are going to be a little more enclosed and generally are poorly ventilated. So as a result, you end up with more ammonia produced out of the bedding, kind of rising up. Animals are going to breathe that in. It's almost going to act similar in a similar fashion to, if you're a smoker, and it paralyzes the ciliary apparatus in your lungs, which also increases the odds of getting some kind of an illness or pneumonia or something along those lines. So keeping that air quality going is really important, just to help prevent some lung infections or lung diseases that are very common in our small ruminant species. The animals really tolerate air movement quite well. If it's extremely cold and they're lambing, of course, you're going to keep them out of drafts and things like that. But keeping doors open and air circulation is really going to be the key to that. Also, giving them someplace that's quiet and comfortable to sleep. That may sound a little bit, basic, but essentially it's the same thing in our animals as it is in us. If it's 100 degrees during the day, and those animals need someplace where it can be cool and at least get down to hopefully 70 at night, where their blood pressure can drop, their body temperature can drop, and they can kind of relax and recover from the heat of the day and the stress of the day. It's in the summer times when it's 100 during the day and 90 at night, and it never gets that real break in their system. You'll definitely see decreased conception rates or increased ewes that recycle or extended lambing intervals. And that also ties into what we need to think about as far as our normal circadian rhythms for small ruminants. So since they are a short day breeder, which means that they cycle naturally when the daylight is shorter and the nighttime is longer. And essentially what that is doing is allowing the melatonin to increase in their system, which is correlated to their natural normal cycle, which would occur if they're in the wild. That would occur in September, October, November, and then those lambs would be born when the green grass is coming on, and they're not going to struggle as much for feed resources. So in what we do, what most of us do, where we're trying to breed in July and August, then that even becomes more important, that they have some dark periods in the barn at night to be able to try and get that natural system going. And genetics it can never be overstated, the impact of genetics. So when you look at the various breeds that we work on throughout the course of the year, there are certain genetic lines, or certainly different genetic breeds, but within certain breeds, there'll be different genetic lines that have a greater ability to breed out of season, or when it's June, they still conceive as well as if it's in September. So those kind of things impact us. How efficient they are with converting feed and responding to diets and things of that nature also are going to be greatly impacted by the genetic makeup of the animal. Do you have questions?
Hey, Tad, we had one question come in on, it's a nutrition question. So I don't know if you want to answer it right now or if you want to wait. The question is, you mentioned corn being not good in hot weather. Would you suggest replacing it with barley?
Barley is certainly a better choice than corn. Yes. Yeah.
Okay.
So your other alternative is if you need to, you could always increase some of the fat in your diet as well and help to restrict some of your corn usage. So my goal is through the summertime to not be over 25% corn in the diet. It's kind of the reference I use. Okay, level 2. So this is going to touch on the animal welfare side of things. Sometimes when I use that word, people get a negative connotation, but it's actually not. I think animal welfare is something we all need to be mindful of, and it actually ties into just the overall wellness and how well we are able to take care of these animals. So protection from the elements or stress. Stress is going to be a big thing that we have to manage, whether that's environmental stresses from poor nutrition, heat through the summer. Any of those kind of things are going to impact us negatively when we're trying to get these animals to breed, especially when it's early in the season or out of season. Obviously, predators is kind of a given when Wile E. Coyote's out there running around. Then also protection from the pathogens, so whether we're vaccinating against viruses or whether we're deworming against parasites. And our goal is really to have all those practices done at least 6 weeks prior to the breeding season, so that we're not. The one thing we've dramatically will see is if in a program, if vaccines are given too close to the time that we're trying to synchronize them for breeding, it will definitely negatively impact their entire system. It impacts their ability to conceive. It's just an additional stress on their entire system. So trimming feet, we've been fortunate to be foot rot and foot scald free for more than 25 years. It's one of those disease processes that a lot of people live with on a day-to-day basis, and I'm a firm believer that we can eradicate it and keep it from our programs. We'll talk more about that a little bit later, but preparing your feet, again, reducing the stress of lameness and things of that nature are going to benefit you. Getting ready to get these animals bred, vaccination protocols, deworming. I'm a very big proponent of judicious deworming, though, not just deworming for the sake of deworming. We need to make sure we're being mindful of those products, because at one point we're going to run into a situation where they're going to quit working on us. So we need to be mindful of how we manage our deworming. Shearing, again, body condition, which we've already talked on. So as far as managing heat stress, one of the strategies we like to try and look at is getting the sheep sheared so that we actually have some fiber length or fleece length back by the time the heat of the summer arrives. So we shear a big chunk of our ewes here in March. We did last week, sheared 300 ewes last week, and we'll do another shearing coming up in May, about another. Essentially, by the middle of May, if we can have those ewes slick 3 days, as the heat of June and July start to roll around, we actually have some increase in our wool length and our staple length, which helps to dissipate heat. And for years, we used to try to shear, when it was hot, to have as little wool on them as possible. But if you ever take an animal that has, say, an animal has several inches of wool, and you shear and you make one pass down their back and you lay your hand on the skin of their back, it is shocking how much cooler they are at the skin than it is within the environment. So there's a beneficial value of how the animal can dissipate heat as through that wool fiber, as the wool fiber is a hollow core fiber, so they can actually increase the surface area and dissipate more heat with having a little bit of fleece on them. So stress is one of those kind of elusive things that kind of float around out there. Sometimes it's hard to define what is stress. Getting the vaccinations and that out of the way 6 weeks prior helps to reduce their immune system going through stress when we're trying to breed them. Getting their feet trimmed and foot health in order, all those kind of things help us way ahead of time. Transporting, transportation is an interesting thing. If you look at over the years, if you load your sheep up on a trailer and you haul them around for an hour, bring them back home, turn them in with a ram, they probably are going to cycle right away and breed pretty well. You'd often see that in programs where people were sharing rams, bringing one flock keeps the ram and the ewes in one spot, someone else hauls them into that location. Person that hauls in gets their animals bred faster than the person that kept them at home. So transportation stress has some interesting benefit at that kind of instance of breeding, but if you are transporting them shortly after breeding or after insemination, you actually decrease conception rates there. So rough handling can be another big stress on these animals, especially if they're doing something they're not familiar with. So we are a big proponent of low stress stock handling. So one of the things that we have started to institute in our facilities is so we have a working chute system, but instead of using a tub system, which is the most common system you'll see most places, we actually use a system that's called a bud box. Bud boxes were developed by a person who predominantly was working where these animals don't go through the stress of going through a tub and through the working chute. And with sheep, they actually move quite well and flow through. If somebody's interested, I can email you a video later on our working system and how it works. It's very simple. It's actually less expensive than a tub, and it's a lot less stressful to the animals. Number 3, co-mixing. So within our system, within our company, we bring multiple animals in. So we service customers from a cross-section of 28 different states. And so we will bring in animals here through our donor program, and our average person probably brings in 2 to 4 donors, and our average days are 15 to 18. And so we will group those animals based on the date, the breeds, body condition, and those things. We want to get that done well ahead of time, because even if all these animals go through quarantine and are isolated for a period of time when they come in, but even 3 or 10 healthy animals mixed together from 4 different locations are going to share different bugs. So it's like when kids go to school or people go to a baseball game or a football game, they're sitting next to somebody and everybody else has something a little different in our immune system. So they're going to exchange bugs along the way. That's one of the things that always impacts when breeders come together. That always makes me kind of nervous is what is each of those flocks bringing together and sharing different bugs that could impact them, even either in the short term of the breeding season or even in the long term of later on when they're late gestation, abortions, and things like that. And then also nutrition and feed changes, making sure we make all those changes slowly to the system. Even if we're getting a new batch of hay and one hay has more protein or more alfalfa in it than the grass that you were feeding, blending all those things can be beneficial in avoiding some of those abrupt changes. I'm going to bang along here a little bit more on foot health. This is a big stickler for us. So eradication of foot disease, I think, is critically important. It's one of those things that the amount of dollars, investments, and time wasted that people deal with every day in dealing with foot health is a huge number. And if each of these people were actually paying for that time if it was a true, if it was truly having to pay someone to do all of that. I mean, obviously you're buying the medications, but if you're paying someone to do that, the money loss in that would be just staggering if we actually knew what it was. So I'm a firm believer that we can eradicate it and manage the animals coming in to clean them up and eradicate them so you don't have to deal with them. With this point, during the peak of our breeding season, through our facilities throughout that middle of the summer period, and there would be no way in the world to manage foot disease. So we eliminate it and cut it off before those animals come in, and then they go into a clean facility. So again, more details on that if anybody's interested, but that's certainly a key. Vaccinations are going to tell you that they're going to be catered a little bit to each of the individuals, each of the individual production systems. There's going to be a lot of different approaches to vaccines. Some folks out there vaccinate for everything that they can. Some people don't vaccinate for anything. And one mindset is that, vaccines aren't the greatest, and so why should we waste the money on them? Let the immune systems develop on their own. And some people have a justified reason there. Other people say, hey, the exposure is too high, and it's the best that we have. In our production system here, given the cross-section of animals that come in, we vaccinate pretty heavily for T, because most of the animals here are going to go through some surgical procedure through the year. So I want to make sure we booster that tetanus vaccine. Pasteurella is a really good late gestation vaccine to benefit you in your lambs. The other Clostridial cerevars beyond CD and T, if you have any exposure to cattle along the way, there's a Clostridium type A, which can be of value. We've seen issues with that in the animals that are also grazed around or behind cattle. Leptospirosis is one that is less commonly talked about, but if you're in the country and there's deer movement or any kind of water near them, certainly think leptospirosis is one that we need to be beneficial of. We could certainly result in some embryonic loss and some. I'm not a big fan of it. That's a really tough one to really not very good, and can actually cause some reactions in the animals. You got any questions? Anything else?
I got a few questions. First question is, can deworming be substantially decreased or rarely needed by strict rotational grazing practices?
Yes, certainly can improve it and decrease it significantly. I think if keeping in mind the parasite life cycle and making our rotations and not allowing those animals to graze those paddocks down so short can certainly benefit from or help to decrease that amount of deworming that needs to be done. Also, doing some fecal counts. You may not necessarily always be able to get the individual fecal egg counts, but you can certainly do some batched or grouped fecal counts from your lots and actually find out what your parasite load. The eyelid test is kind of one of those that honestly I think when they get that, once an animal starts to lose that kind of color in their eye, that's an indication of anemia or loss. On, in my opinion, but certainly if they're more pale in their eyelid, they definitely need to be dewormed. So all those are definitely benefits in that, and rotational grazing can be a real value to it as well.
And one thing also, we did have a webinar last summer, and it's archived on our Facebook page and on the website that talks about parasite management. So that might be something that this gentleman can take a look at too for more details. Another question, when should rams be shorn?
Yeah, I like to shear them, by that May 15th period or even a little ahead of that. I prefer to have it all done by April 15th here if we can, so that the fleece regrowth on them again, helps to protect those animals. And then depending on where you're from, so we have customers, that are in the Southwest, where the bugs and the flies and things like that, fly strike can be an issue. So again, being earlier in the year, it might benefit you in that region of the U.S. If you're in the Midwest, I would say no later than May 15th, if not, the middle of April is even potentially better.
One last question before you move on. Would you advise to include corn in the winter feed to assist with body heat?
Not necessarily. So we have a set of ewes that we run that live outside all year. So essentially we wean them in November, and they were sheared back in the spring. We keep them in good body condition, and they live outside all winter with no shelter and eat soy hulls and hay, and that's how they live all winter. So corn's not necessarily required for that. The place where corn comes into value is, again, tracking that body condition, and in that third or like the end of their gestation, where they need a little additional energy, they're trying to keep up with their own body condition as well as feeding lambs. That's where I like to add in that corn. And then once we start into lactation, that's where I'm going to ramp up. That corn might actually be 50% of the diet when they go into lactation, and protein is going to go up to 16% on these lactating ewes. So we're going to crank it up on them. Like if I'm going to pile in the concentrates to a ruminant, small ruminant animal, it's going to be in lactation. So more corn, more protein. If your ewes need to, they could go up to 60% corn in the diet during lactation, but not necessarily just because it's wintertime.
All right, that's all I see for questions right now.
Okay. So we're going to spend a lot of time on level 1 and 2 of our pyramid. Level 3 is reproduction. If we can get those things in check, get those things covered, then our ability for successful reproduction goes up. So we can't change that genetic potential of the animal. All we can do is hope to maximize it. And so that's where everything we've covered so far in our system is trying to maximize what that genetic potential is for those animals. And I think the one big thing too is remembering that breeding management is actually a 12-year or 12-month program. So every animal is in some phase of production at any given time. So if they're in the dry period, then that we manage them one certain way in the dry period. If we're in the breeding phase, we're going to manage them differently. If we're in gestation, we're going to manage them differently. And if we're in lactation, we're going to manage them differently. The rams are going to be more of breeding season, not breeding season. So that's going to be a little different. But we got to keep an eye on those all 12 months, no matter what phase we're in. The places we see trouble is when these animals get they kind of get out of production phase. So they're in dry phase, or they're not in the breeding season for the rams, and they get kind of left forgotten, or a little too skinny, or their feet are a little too grown out. Things like that can be a problem. Via 12-month program. Okay. All right, so we're going to move into a little bit more specifics on rams. So semen collection. Common reasons to collect semen on the ram would just be simple breeding soundness exams. We really recommend that every person gets their rams checked prior to the breeding season. More often than not, we'll have, every single year we end up in a scenario where a customer calls up and say, hey, all my ewes are recycling, or, something's not right. Bring the ram in and he's sterile. And now maybe headed off earlier. So a pre-breeding breeding soundness exam, have your local veterinarian take a look at them from a health standpoint. They're going to do an examination, listen to their heart, lungs, palpate their testicles, make sure there's no lumps or bumps, anything indicate a problem from their testicle standpoint. Do a semen just make sure they're ready to go. It's just going to cut, head off a lot of headaches down the road. So the second reason obviously would be for semen freezing to use later. So you kind of freeze up some product as an insurance policy on the ram. Ram gets sick, he gets injured, he passes away, dies. You've got some frozen product to maintain those genetics on that animal. And then we also do quite a few fresh semen collections for short-term use. So we'll collect it, process it, and maybe we'll inseminate a big group of ewes that same day. So we may have a flock that purchases a ram and they want to breed 20 to 200, whatever that number is, to a ram. We can do that in a single day. So we can collect that semen, or maybe there's 5 guys that have gone in and purchased one ram. They all want to use him at the same time. So we can collect him fresh and inseminate as many ewes as possible to the same animal across the day. So two most common ways, artificial vagina, which is what you're seeing there in the picture. It's basically a hot water device that allows that animal, that ram, to inseminate into that collection cone. That's the preferred and the best method. Second best method is going to be electroejaculation, where you have either one of the handheld probes or one of the box probes, pulsars 4, which goes into the rectum of the animal, creates a little bit of a electrical stimulation to create ejaculation to occur. So in a semen evaluation, you're going to take a look at initially, you're going to take a look at the volume, which is just the amount, milliliters of the raw ejaculate. Second thing we're going to take a look at is the concentration. So essentially that is how many sperm cells are in that sample, or how many of those sperm cells are in a given volume of ejaculate. And then from there, we can actually start to do some calculations with to create what our sperm count's going to be. Certainly, you're going to take a look at live rate and make sure that there's a majority of those sperm cells are swimming. So if you end up with less sperm cells, so if your concentration is 1 billion and only 50% of them are alive, and you've got 500 million live cells, that's actually not a very good sample, but it's a quick example for the math to kind of grasp that a little bit. So the minimum number of cells that we want to be alive to do an artificial insemination is going to be about 30 million. And if we're going to freeze that product, we're going to actually package about 80 million into a single straw of semen to kind of give us a little bit of a wiggle room or hedge the numbers there a little bit. So when you start to look at the live rate of a raw sample, so it's very common to have a ram be 80 to 90, 95% live cells on a raw sample. When it comes to a frozen thawed product, you're going to be closer to anywhere. Our cutoff is 50% live, so we'll run somewhere between 50 and 70% live post-thaw. So you'll never get I won't say never, but you rarely would get a sample, frozen thawed sample greater than 60 or greater than 70% live cells post-thaw. So linear progression simply means, are those sperm cells able to swim in a straight line? So when someone's evaluating a sample, you can have a ton of movement. The whole screen can be wiggling and moving. But if they're spinning in circles or they're swimming little ways and then turning different directions, then they're actually not the ones that are going to be the most likely to fertilize. So linear progression just refers to, is that sperm cell swimming over a given distance in a straight line. Speed of the cell is one of those things that we found that if the sperm cells are too fast or hyper excited, then their life expectancy goes down because they burn up their energy reserves. If they're too slow, they don't seem to make it to where they need to go either. So you kind of have to learn, they're swimming fast enough essentially. And then probably the other big one that we deal with is morphology. And so again, you can have a good collection. There can be a lot of movement on the screen. When you start to look at the cell structure or the morphology, which is basically what is the form or the structure of a living organism. Then the if there's a significant amount of abnormalities, that's going to in fact impact conception rate. So they get the head, the midpiece, and the tail, which can all have some kind of an abnormality to it. If you get greater than 20% abnormalities, you're certainly going to affect conception rate. We try to maintain 15% or less in our frozen thawed products is what we try to do through our lab here. So this is going to overlap here a little bit on frozen thawed semen. So you're typically going to see those either in 0.25 or quarter mil straws, or 0.5, which are half mil straws. You're going to see those two volumes commonly here in the U.S. Again, 30 million live for your insemination dose, and our cutoff is 50%, 50% post-thaw. So if you get over that one, it just kind of is a general indication that there's probably something wrong with that freeze-thaw process, and we just generally see a decrease in conception rate. The more dead cells we have in the ejaculates, it just seems like it negatively impacts the uterine environment, and so we just try to steer clear of those. Again, motility moving in a straight line, morphology we already talked about. So semen evaluation, whether it's fresh, raw, or frozen thawed, it's going to be very similar to each other. You have any questions on that?
I don't have any right now, no.
Okay. Okay, so female programming. Oops, I guess we're on movement here. So talking a little bit about the, sorry guys, let's have a timer on this slide. Estrus cycle, so that's the heat cycle. Again, we talked earlier about them being short day breeders, so they naturally breed the best in the fall season, which is when the daylight is shortest, nighttime's longest. So that's a decreased photo period. So with sheep, we're going to be on a 17-day cycle, and they're going to ovulate somewhere 18 to 24 hours following the onset of heat or estrus, when they start to stand for the male. Everybody's probably been familiar with the signs of estrus: edematous vulva, standing to be mounted. They'll have a clear to milky vaginal discharge, which is all good indicators of a nice heat cycle. So wanted to share this slide. There's several things going on there. First off, kind of notice the progesterone hump in the middle. And so as we move forward, we talk about some of these products. So progesterone is the cedar that we're going to talk about synchronization here in a second. Progesterone is released from the cedar. So you're going to have this cedar goes in, and progesterone is going to simulate that. This is a natural cycle as well, but we're just going to affect that with the hormones that we're giving. So as progesterone starts to drop or tail off here, then estradiol or estrogen goes up, and that's a result of the follicles on the ovaries going up, and the egg is inside that follicle. And then we have a spike in luteinizing hormone and a decrease in estrogen, and that's when ovulation is going to occur. Is you can see over here on the left side of that diagram, ovulation is going to happen right after the estrogen drops, LH spikes, ovulation is going to occur. And so as that peak in estrogen occurs, that's where the strong heat is going to be, and the animal is going to get bred by the male at that point. So some of the synchronization devices that we're going to use, you can see here in this T-shaped structure, that's a cedar. So that's going to go, it's an intravaginal device, going to go in, and those wings are going to open up. It's going to sit in the vaginal vault up near the cervix and release progesterone into the system. Number 2 is prostaglandin PGF2 alpha, which is going to get rid of any corpus luteum. So the best product out there is a product called Estromate. And so where that's going to be effective is right here where the progesterone levels is high. That progesterone is being produced by a structure called the corpus luteum, which is on the ovary. And so when you give estromate or you give prostaglandin F2 alpha, that's going to get rid of or kill that structure that's creating the progesterone. So you can imagine if you give PGF2 alpha here in the middle of that hump, then this progesterone is going to drop sooner back in here. The estrogen is going to go up. So that's called short cycling. So you can actually help to control that cycle through the use of a prostaglandin product. Then number 3 is PG600. PG600 is a combination product of PMSG and HCG. PG600 is the one that's available on the market here in the U.S. Although it is made up of PMSG, the USDA has never officially approved that as its own hormone or its own drug. So we have to use the PG600 at this point. But that's given at the time that the cedar gets removed. And then certainly the other things that are going to impact our heat cycle is going to be the male effect. So either the ram's going to be turned in, teasers to help induce that ovulation. So if we were going to do then, and this is a protocol that can be used very similar for natural breeding or artificial insemination. So you introduce the cedar on day 0. Day 12, give a 1 milliliter injection of estromate into the muscle. And then on day 14, remove the cedar and give an injection of PG600. Day 15, we're going to introduce the RAM or teaser. And then if we're doing laparoscopic artificial insemination, we're going to breed them on day 16. So that's a very basic schedule, which would work for artificial or natural insemination. So if you're looking at the basics of artificial insemination, so they're going to be they're going to be placed on the cradles. You can see in those pictures, they'll be on their back. They're going to shear a spot in their belly, basically from the udder to the umbilicus and over to the flanks. And then they're also, prior to that, it's going to be under a mild sedation. So they're going to be kind of relaxed or knocked out just a little bit. The insemination process is going to happen, as you can see in that lower right-hand picture. Once we're done, we're going to give them a prophylactic antibiotic and spray the sites to where we went in with our trocar and cannulas. So as you can see in this picture here to the right, there's an eyepiece, a laparoscopic eyepiece here, and then the right hand is holding the insemination pipette or the working system over here. It's a very low complication rate when it comes to artificial insemination. Those animals have been fasted for a full 24 hours. And so you have to remember that that rumen is full of feedstuffs, and it's a very large, several gallons of feed and water in it. So when we take them off feed, they're going to spend at least that first 24 hours digesting what's already in the rumen. So even though they're off feed and water, they're really still using and absorbing what's in their system. So during that time period, it helps to empty out the rumen, empty out the intestines. And as long as that protocol is followed, the complication rate's very, very low. Okay. And then just to touch briefly here on embryo transfer. So embryo transfer is a way to help shorten our generation intervals, increase the number of offspring per female or even the male, and then prolong the productivity of an older or disabled animal. So instead of a ewe having 1 to 2 lambs in a year, she may be able to have 4 to 10 embryos or 10 animals in a year, depending on her embryo production. So this is a similar protocol to the AI. The cedar is going to go in on day 0. Estromate's given on day 7. And then days 12 through 15, they're going to receive phallotropin, which is an FSH product or a follicle stimulating hormone. that's going to super stimulate the animal and allow multiple eggs or multiple follicles to be developed on the ovaries. Then on day 14, we're going to remove that CEDAR. So we're taking that progesterone source away. They're going to go through the ovulation period. Day 15 is introducing the teaser. Day 16 is going to be the artificial insemination will be performed. And then day 22 will be embryo transfer. So if you're breeding goats, live cover works exceptionally well. It's actually the preferred method to breeding the donor animals. If you're raising sheep, then live cover does not work at all. Rarely, over the course of a season, we'll do quite a few of these, and on occasion, someone just can't get it done, and so they do the live cover, and you'll have one in 100 that'll actually be successfully fertilized embryos. So the embryo transfer is a surgical procedure. They're going to be placed on their back under general anesthesia, and then right of the midline will make a small incision to exteriorize the uterus. So you can see in these two pictures, those are the two uterine horns, and each of those horns will be catheterized, and a wash will be put through those to pick up any eggs that are floating in that horn. Then they'll be collected into the plastic dish below. Our trained embryologists will then take the embryos and evaluate them. And so there's a International Embryo Transfer Society, or IETS, and they have set out these international standards for grading and evaluating embryos. And that evaluation process, the good quality embryos will go through a wash, an incubation period, and getting prepared for transfer into the recipient or the surrogate. It's a picture here of them going in, embryos going back into the surrogate or recipient ewe. And so we've laparoscopically evaluated the ovaries of this ewe and making sure that her timing is correct with the donor animal. And then those eggs, one or two eggs, we passed back into the recipient. So again, overall success for any of this. Quality semen, proper program management, and then the experience of your veterinarian doing the work will all impact your outcome. So we'll artificially inseminate somewhere around 15,000 ewes on average. Some people will, if they're doing 5 animals, they may get all 5 of them or 100%. And then, of course, the averages are averages for a reason. The 30-year average in embryo transfer is 6 embryos per donor. And so through the course of our season, we'll do about 1,500 of those surgeries annually. And you'll see that time and time again, it comes back to about a 6 average in sheep. Now, if you're raising goats, you're going to be closer to a 8 to 9 average on them. With your 5% and frozen embryos somewhere around 50%. So a frozen thawed embryo closer to 50%. So I'm just going to touch briefly here on technologies that are just now available here in this last year is gender sorted or sex sorted semen to increase the number of males and females. So we basically take that raw ejaculate and it can be split into 90% accurate male sperm or 90% accurate female sperm. Do you have any questions?
One question is it cost effective to do embryo transfer?
So cost effectiveness on embryo transfer is probably only can be determined by the breeder. And so if you buy the drugs and have the recipients and you hire us to do the surgery and you end up with a 6 embryo average, you will have invested somewhere between $850 and $1,000 in that set of embryos. So then from that point forward, it's more cost effectiveness is more related to the genetic potential on those animals or the marketability of those animals. So can you raise those animals with that in mind for less money than what you could go out and purchase them? Or can you sell those animals for more than what you could the other animals in your farm? So that's basically what the basic cost of it. If depends on what your market looks like.
What's the timeline for communicating with you or anyone that's doing this procedure for AI and for ET work? How far in advance do you need to be contacted to set up scheduling?
The sooner the better. So like for us personally right now, our calendar is built very solidly all the way out through the middle of June, and we're already booking July and August. Actually, we're booking the entire last part of the year, but July and August are getting booked very heavily right now, because that is such in the Midwest, July and August will be the real big seasons or times of the year. And then September, October, November are going to be more like in the Southwest. The May calendar, depending on where you're at geographically, the quicker that we can start that communication process, the closer we can get you to your ideal dates.
Anybody else have any questions? We'll give it just about a minute. We're a little delayed on Facebook from Zoom, so we'll let that catch up.
Okay.
I'm seeing if questions come in. Ted's email address is posted here on this last slide, so if you have questions for him or his staff, you can go ahead and email him anything you have.
Sounds good. More than welcome to send in questions.
All right. Thanks so much, Ted, for taking time to speak with everyone tonight. We had about 60 viewers, so that was great. We had a great audience between Facebook and Zoom. Again, this will be archived and put on our website. Oh, looks like a question just came in. For the PG600 injection during synchronization, is the dosage different for a different size sheep?
Yes, different breeds and different ages would be looked at a little bit differently. And so probably our traditional recommendation is going to be a 3 milliliter dose of PG600. If you're doing more prolific breeds, say you have Dorpers or some of those different hair breeds that are, like say, more prolific, you might be at 1.5 to 2 mils. Or if you're out of season with a large frame blackface breed, you might be closer to 4 or 5 mils on that. So average is going to be 3, and then it's all going to be adjusted based on age and breed type. It's a good question.
All right. Last question.
Okay.
Thanks again for your time. Thanks everyone for joining us, and have a good evening.
All right. Thank you.